Hey guys, Mr. Barnes here, bringing you a math video on my absence from class, and anybody tuning in from YouTube, you're getting a glimpse into my lessons. So thank you for watching. In this lesson, guys, basically we're going to start Unit 2, which is trigonometry. So trigonometry is the study of angles and triangles and things like that. And this seems complicated at first, but is actually not, so don't panic. Today we're going to talk about the three primary trig ratios. And sort of a prerequisite to being able to do those is being able to label a triangle in relation to one of its acute angles. So if I look at this triangle here, I'm going to label it from the perspective of angle A and then from angle B. So A being here and B being here. So this guy is angle A. So you probably know one of the sides of the triangles. It's called the hypotenuse. So it's along the side of the triangle and it's directly across from the right angle. So this guy is the hypotenuse. So there are two other sides of this triangle that we need to be responsible for. So the other side is the opposite side. So directly across from this angle, right over here is the opposite side. And then directly across from the hypotenuse, or touching, like I usually don't say that, but usually what I say is touching this adjacent side right here. That's the adjacent. So touching the angle is the adjacent side. Didn't say that very well. Alright, so the thing that's unique about the adjacent and the opposite side is that they can switch depending on the angle that I have. So if I have this right angle right here, directly across from it is the hypotenuse. And then this angle up here, angle B, directly across from it down here is the opposite side. And then touching the angle is the adjacent side also. Touching the angle is the adjacent side right there. Yeah, that's the best way to think of it. So before we do any of these questions, we need to be pro stars at this basically. We need to be awesome. So let's look at the next example. So it says label each of the following with respect to angle theta. So theta is a Greek letter, and we often use it to denote an angle. So sometimes we use a letter, like in the last one we use angle A and B. Like we could use C here, and angle D, and angle R, and stuff like that, and angle T. But a lot of times we use theta, and that's personally what I use a lot of. It's just like a variable. That's all it is. It's a number, whatever that angle happens to be. We don't know what it is, so we just put something there to represent it. So in this case, we use theta. So I have an angle here. That's the one we're going from. So this is my hypotenuse. I'm just going to use H, O, and A for this. My opposite side directly across here is O. And then touching my angle is my adjacent side. That's it. Really, that is it. We just need to be able to do that really, really well. So here's my angle again. Make sure you note where it's to. This is my hypotenuse. This is my opposite side. And then this is my adjacent side. Same thing with these two right here. I kind of misorder it, but that's okay. A, B, B, C. I forgot about the letter D. That's okay. Alright, so we have my hypotenuse over here. That's my hypotenuse. This guy is my adjacent side, touching the angle, and then my opposite side right here. Really quick, this is my hypotenuse. This is the angle here, so opposite and adjacent. Alright, so you'll see exactly why that is important right now. So these are my three primary trig ratios. So you've probably seen these on your calculator, and you've probably been wondering what they are since like grade 7. So they are sine, cos, and tan. So sine, cosine, and tangent. So all these are, guys, are ratios of sides of triangles. So, for example, the sine function is the ratio of the opposite side of the triangle divided by the hypotenuse. So if I know what the angle is and I put it into my function, it computes the opposite side over the hypotenuse side. It's just like if I have a linear function and I put in a number, it gives me back another number. So that all this function does is that when I put an angle in, it gives me back the ratios of sides of triangles. That's all it is. Nothing more to it than that. You probably still don't understand the words that are coming out of my mouth right now, but eventually it'll start to sink in once we see some examples. So be patient, it'll come to you. So right now, all we need to recognize is what the formulas are: sine, cosine, and tangent. So a lot of my students like to remember this formulas by remembering Mount So Ka Toa. So Mount Sokotoa. So I don't know where that comes from, but somebody said it to me a few years ago and it makes sense to me. So Mount Sokotoa, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent. So I'm going to do, I'm not going to do every single question here, guys. I'm just going to do a couple and give you a sort of a brief overline. I think I'm just going to do one. Well, I got 3 of them here. I'll do the first one, and you guys can do the next 2, because they're exactly the same. So first of all, we need to recognize we're just writing the ratio. So we got to recognize what angle from, so angle D, so highlight that angle. So there's angle D, and then we label our triangle. So this is the hypotenuse side, directly across on the right angle. Here's the right angle, it's not labeled, but anyways there. This is the opposite side, 3, and this is the adjacent side, 4. How many minutes? So 6 minutes. Alright, so all we need to do now is list out our functions. So we're doing a sine. So note this A, guys. So if you look this angle A, that could be anything. It could be theta, like we just had in the last one. Like this one's going to be D. So it could be any single letter that you want it to be, just like X. So it's just you choose it, or the triangle tells you what it is. In this case, it tells us from D. So we do sine of D. Generally, guys, these are lowercase, so I'm not going to get that picky, but generally that's how it is. So sine of D, and some people like to put the angle symbol in there. I don't like to do that because it kind of clutters things up. So sine is opposite over hypotenuse. So again, we're looking for ratios of sides of triangles. So I just have a note with my opposite one is 3, and then my hypotenuse is 5. There we go. Cosine of A is equal to, so if I get cos of A, so let's see, so cos is adjacent over hypotenuse, so I just need my adjacent side, which is 4, over my hypotenuse side, which is 5, just like that. So I'll do the same thing. Tan, I don't know why I wrote A there, it should be D. My apologies. You guys are all looking at each other and saying, what's he talking about? So tan of D is equal to opposite over adjacent. So we got the opposite side 3 over the adjacent side 4. There we go. That's all it is. So those are my sine, cos, and tan ratios. So recognize, if I knew what angle D is, and well, I can kind of figure it out because I kind of know the game. I know how this works, right? So my computer's going crazy here. Hang on now. So I know that this angle here is about 37 degrees. Alright? So if I put sine of 37 degrees in my calculator, and you can try this. Now it's not going to give you back exactly 5 over 3. So sine of 37 in my calculator gives me 0.601. Now if you do 3 divided by 5, of course that's 0.6 itself. So it's getting me really, really close to it because I rounded the angle when I calculated it. And you'll be able to do this in a couple minutes. So recognize that's all it is if I know the angle, then I know the sides, the ratios of the sides. That's all it is. That's what the function does. It's just like pre-programmed. Put the angle in, it shoots back the ratio. That's all it is. That's all that function does. Alright, so there's 2 more here, guys. I'll do the next one, and you guys will get C for me on your own. So let's try to label this guy again. So we're doing it from angle A this time. So up here. So then my right triangle is here. So this is my hypotenuse. This is my opposite side, and this is my adjacent side. So don't get the A's confused. They're completely different. It is what it is. Alright, so let's see. So we're doing sine of angle A. That's why some people like to put the angle sign in there so they don't get them confused. But anyway, it doesn't really matter. So sine of A is equal to opposite over hypotenuse. So that would be opposite 12 over hypotenuse 13. So 12 over 13. Cos of A is equal to adjacent over hypotenuse. So adjacent being 5 over 13. And then tan of A is opposite over adjacent. So opposite being 12 over 5. And there it is, guys. So you guys do the same thing with the next one there and see if you can't figure that out. And I think there's a couple more that comes after this. You can skip those for now and keep watching the video. So just skip down. I think this is just on the bottom of the next page. And you can come back and try those after, or we can wait till I get back. Alright, so this one's asking us for sine, cos, and tan for this triangle. Now the only problem is we're missing a side. Now luckily this is a right triangle, and everybody's favorite formula is c squared is equal to a squared plus b squared. So I need to be able to solve this, guy, so I'm just gonna, I need to get this basically this you know, this side right here. So I'm going to use Pythagorean theorem. So let's sub in some stuff. So it's going to be, I'm going to rearrange this, guy, so it's c squared minus a squared is equal to b squared. So I'll do 29 squared minus 20 squared, and I'll say that's equal to b squared. I'm just going to label this guy down here b squared. So I'll do the math on that. So b squared, so 29 squared, I don't know why it keeps doing that. 29 squared minus 20 squared. That's equal to 441 square root 441. That's equal to 21. That's equal to 21. Alright, so this guy down here is 21. So now I need to be able to do sine of A, cos of A, and I'm going to change this to tan of A, so I'm just going to be lazy. So A is up here, so this is the hypotenuse side, this is the adjacent side, and this is the opposite side. So again, that's really important to be able to do. So let's do sine. Sine is opposite over hypotenuse, so opposite 21 over hypotenuse 29. It's 21 over 29. Sine, or cos, sorry, of angle A is adjacent over hypotenuse, so 20 over 29. And then tan of A is opposite 21 over adjacent, so 21 over 20. There it is. Now if I did want to find tan B, I will find it here now just for the sake of being educational. I would have to relabel my triangle. That's the important thing to remember. So the hypotenuse, I shouldn't erase the hypotenuse. The hypotenuse is not going to change. That's still going to be the hypotenuse. But since we're changing the reference angle, or whatever the angle that we're going from, these are going to switch. So this one is now the opposite, and this one is now the adjacent. So note that tan of B is going to be 20 over 21. So if you ever kind of want to just, you know, be able to find from the perspective of the other angle, you have to make sure you relabel these opposite and adjacent ones. Alright, so sometimes this is an important question, guys. Good test question, great test question. The reason being is Pythagorean theorem and right angle trigonometry are used a lot together in test questions. Alright, so let's look at our next big topic in this, which is being able to find the angle of a triangle. So that's another thing that's really useful. So if you look on your calculator and you see sine, cos, tan written there, if you look above each one of those, you'll see sine, cos, and tan all with a little -1. What that -1 means is they are inverse functions. So inverse, sine, cos, and tan are used to find angles. So they're special functions, alright? So they're used to find angles only. Inverse functions is like a huge topic in math, And is not your objective here to be able to understand where this really comes from? But basically, what they are used for is to find the missing angle. So when I have a ratio, I can find the angle that it creates, and that's what I did earlier in this video. So if I look at this triangle here that I have, well, actually, if I look at this ratio that I have, and in here is an unknown angle A. I don't know what it is. Sine of something gives me 35 over 37. Well, if I know that, I can rewrite this guy like this. So angle A is equal to sine -1 over 35 over 37. So now if I work this out, so in my calculator, this is what you should be listening to me. I wish I could put this up on the screen. I can, but it's just I don't know where it would be at right now. Let me see. 20 rabbit email, where for art thou? Here we go. See if this works now. We'll get lucky if it does. My virus detector is saying that. Okay, I need a ROM. Let's use this guy. Alright, let's try one more time. Wabbity moo. Please start the ROM. I can do it. Please work. Anyway, guys, this is not going to work. Hopefully it doesn't mess up the recording too much. Terminate now. Close. Alright, so this computer, basically, guys, I broke this out of a box. It's been sitting here like 5 years to make this video. So, sine -1. So what you got to do, go to your calculator and press second function and then sine. So what comes up is sine -1. What we're going to do is we're going to put that fraction in there. 35 divided by 37 and close brackets. And then when we do, we should get 71 degrees. Now, important thing to note is your calculator should be in degree mode. So check that. You know, every calculator is different, so I can't possibly explain that. But for a TI, just press the mode button, and most calculators will have a mode button. But that's all you need to do. If you want to find the angle, you need to find the ratio and then use the inverse function to be able to find it. Alright, so let's go ahead and try this one. So we've already got the ratio, it's 1 over 2. So this is again, this would just be the opposite over adjacent. This was the opposite over hypotenuse. So then we go tan -1 of 1 over 2. That's a -1. So then tan -1 of 1 divided by 2 in brackets. So remember, second function. You got to put second function to get the -1 up there. And that gives me 27 degrees. Alright, let's try this a couple more times. I don't want to make this video too long, and I already messed it up with that friggin' old Wabnimu. So let's see. Next part. So I need to find, I got my ratio given. So angle A would be sine -1. I'll divide it by 3 over 4. And let's see. So we got sine. So second function, sine -1, 3 over 4. And we get 49 degrees. And then the last one here, which looks a bit odd because it's negative. Believe it or not, guys, ratios of sides of triangles, I know it doesn't make sense to you, but they mean other things besides that. So they can be negative, but we'll never really deal with it. Just to show you that you can put a decimal into and find an angle, guys. So this, basically, this ratio was already divided. Like, if I didn't write this as 3 over 4, as I wrote it as 0.75, you would still get the same answer, right? So that's all this one. There was a ratio here before, but now it's just a decimal. So I go cos second function, -0 decimal 707, and we get back 135 degrees. And there it is, guys. That's how your inverse, your second function, cosine tan works. So now we need to apply that to a question. So I've got a couple questions here. I'm not going to do every single one. So let me just try this one. So it says determine the measure of angle D in each triangle. So first thing, again, we need to label this guy. So angle D is right here. So this is the hypotenuse side, this is the opposite side, and this is the adjacent side. So when you have all three sides given, you basically get to pick. So I'm going to do sine, and then I'm going to do cos, and I think there's probably another one. You guys can do tan. So sine of angle D is equal to opposite of 3. So opposite over hypotenuse, 3 over 5. So then, because I'm looking for my angle, I need to take my ratio another step. So this is why we practice writing this, so we can do that extra step to be able to get my angle. So I go D is equal to sine -1 over 3 over 5. And then so I just put that in my calculator. So second function, sine -1, 3 over 5, in bracket, solve, or hit enter, and then we have 37 degrees. So that's the one I showed you earlier, and that's exactly what I did before that. Alright, so I'm going to use cos for this next one. So this next one I'm going from angle D again. So angle D is down here. So I'll do cos. So this is the hypotenuse. This is the opposite. This is the adjacent side. So opposite or adjacent over hypotenuse is cos. So cos of D is equal to 12 over 13. And then that gives me D is equal to cos -1, 12 over 13. And then we just go ahead, cos -1, 12 over 13, in bracket, and that gives me 23 degrees. Alright guys, I hope this kind of helps you some way, somehow, to be able to solve this thing. Let's do one more. So if we flip over to the next page, I think we have here. So it says, find the measure of angle A and angle C to the nearest degree. So we're given a triangle here with only two sides, so let's label it. So let's go from angle A right now. So that's my favorite angle, angle A. So this is the hypotenuse side, which we are not given. We could find it with Pythagorean theorem, but we don't want to do any work, extra work that we don't have to. So this is the opposite side. No, sorry, this is the adjacent side, and this is the opposite side. So because I have opposite and adjacent given to me, that's not theta, that's opposite. Oh. Because I have the adjacent and opposite side given to me, that lines up for tan. So tan of A is equal to opposite over adjacent, so 7 over 16. So then I can do tan -1. I'm looking for the angle, of course, angle A. And then that's 7 over 16. And then I just go tan -1, 7 over 16, and that gives me 24 degrees. So I know this guy right here is 24. Now a triangle only has 3 angles. I know one's 24, one is 90. All of them together should give me 180. So if I want to find angle C, I can go ahead and go 180, subtract 90, subtract 24, and that will give me my angle C. I don't necessarily have to do right angle trig to be able to get that. So this is just using triangle properties like you did last year in grade 9. And that equals 66 degrees. Alright guys, there it is. I hope this video helps you sort through this lesson without me. And thanks for watching. If you're just watching this on YouTube, thanks for watching. Like, share, subscribe, all that stuff. Make me YouTube famous. See you guys in class. Thanks for watching.